Hello friends, myself Professor Rajendra Baburao Gharse, working as the head of Electrical Engineering Department at NB Navle, Sinhagad College of Engineering, Solapur. I am having teaching experience of 9 years. I have completed BE Electrical from Government College of Engineering, Karad and MTech from Indian Institute of Science, Bangalore. In the achievements, I have secured the All India 7th rank in the GATE examination with a percentile of 99.96. Also, I have qualified the GATE examination 6 times. In my last video, we have discussed about transmission parameters or the ABCD parameters, right? Today we are going to discuss about the hybrid parameters or the H parameters. Okay, so first, hybrid parameter or H parameters, right? It is also known as a H parameter, hybrid parameter or H parameter. Okay, so as we know, we are having the 4 types of the parameters: Z, ABCD, Y and H parameters. Okay, we have already discussed about the first 3 parameters. Today we are going to discuss about the H parameter, that is a hybrid parameter, right? So we are having a input port V1, I1 are the variables, and we are having the output ports. The variables are V2 and I2. The H parameter gives the expression for V1, I2 in terms of I1 and V2. H parameter gives the expression for V1, I2 in terms of I1, V2. The characteristic equations are V1 is equal to H11 I1 plus H12 V2 and I2 is equal to H21 I1 plus H22 V2. Okay, these 2 are the characteristic equations of the H parameters. We need to make 2 equations. Okay, now, so in order to find H11 and H21, we need to make V2 is equal to 0, right? So V2 is equal to 0 means output port is short circuited. So if output port is short circuited, that is V2 is equal to 0, right? So when V2 is equal to 0, what will happen? V1 is equal to H11 into I1, right? So V1 is equal to H11 into I1. So from this, what is H11? H11 is V1 by I1, provided that V2 should be equal to 0, right? So it is a ratio of input port voltage to the input port current. So it is a ratio of voltage to current. So it is like a impedance, right? So what is the unit of H11? It is a ohm. Unit of H11 is ohm. Similarly, from second equation, when V2 is equal to 0, this term becomes 0. So what is I2? I2 is equal to H21 into I1. So can we write I2 is equal to H21 into I1? So I2 is equal to H21 I1. So from this, what is H21? H21 is equal to I2 by I1, provided that V2 is equal to 0, right? So it is a ratio of output port current to the input port current, right? Provided that V2 is equal to 0. So it is a ratio of current and current, right? So what is the unit of H21? It is a unitless. H21 is a unitless quantity, right? H21 is a unitless parameter. Next, similarly, in order to find H12 and H22, we need to make I1 to be 0, right? If I1 is 0, how to make the I1 0? For that, we need to keep the input port open circuit, right? So if input port is open circuited, at that time I1 is equal to 0, right? So if I1 is 0, from equation 1 or from first characteristic equation, can we write V1 is equal to H12 into V2. Okay, so what is H12? H12 is equal to V1 by V2. Okay, so it is a ratio of input port voltage to the output port voltage, right? So it is also a unitless parameter. So H12 is also a unitless parameter, right? So be careful. Next, so if I1 is 0, then from equation 2, can we write I2 is equal to H22 into V2, right? H22 into V2. So what is H22? I2 by V2. So it is a ratio of output port current to the output port voltage, right? So it is like a admittance. What is the unit of admittance? It is a mho. Unit of admittance is mho, right? So here we need to remember these units of the parameters, right? Unit of H11 is ohm, unit of H12 it is a unitless, H21 also unitless, and H22 unit is a mho, right? They have asked the MCQs, multiple choice questions on the parameters of units of H parameter and the units of ABCD parameter also, right? So let us discuss one example. Find H parameters of the given two port network. Okay, so we are having here simply two loop circuit. Okay, this is a input port, this is a output port, right? So what to do? By using the KVL we can simplify it. Simply we need to write the equations for V1 and I2 in terms of I1 and V2, right? V1 I2 in terms of, so here we have considered the loop current. Loop 1 current is I1, loop 2 current to apply KVL to loop 1. Okay, so it is V1 minus 1 into I1 minus 3 into I1 plus I2 is equal to 0. So what is V1? 4 I1 plus 3 I2. So next here we are having V1 in terms of I1 and I2, right? So but we require the expression for V1 in terms of I1 and V2, right? I1 and V2. Okay, so we are not having problem with I1, so we need to replace this I2 actually, right? So for that apply KVL to the second loop. Yes, what is the KVL equation? Plus V2 minus 2I2 minus 3 into I1 plus I2. Okay, plus V2 minus 2I2 minus 3 into I1 plus I2 is equal to 0. Rearranging the terms, so we can write I2, right? Because we require the expression for V1 and I2. Okay, out of that I2 in terms of I1 and V2 we can get from the KVL to the second loop, right? So I2 is equal to minus 3 by 5 I1 plus 1 by 5 V2, right? So it is like I2 is equal to H21 I1 plus H22 V2, right? So what is H21? It is a minus 3 by 5. What is H22? It is a 1 by 5. Okay, next similarly here can we put these 2 in equation 1, right? Means we need to replace I2 in equation 1 with equation 2, right? So here we can write V1 is equal to 4 I1 as it is plus 3 into, instead of I2 put this equation, right? So it is minus 3 by 5 I1 plus 1 by 5 V2. Okay, so therefore what is V1? V1 is equal to 11 by 5 I1 plus 3 by 5 V2. So we are having V1 in terms of I1 V2, similarly I2 in terms of I1 V2, right? So H11 is 11 by 5 ohm and H12 it is a 3 by 5, right? H21 minus 3 by 5 and H22 it is a 1 by 5, right? So are you getting the point? Ultimately our task is to write the expression for V1 and I2 in terms of I1 and V2, right? In terms of I1 and V2. So this is a simple example for understanding the hybrid parameters. Let us discuss some more examples. So suppose we are having a question like determine hybrid parameters for the network shown in figure. Okay, this question has been asked in the Solapur University examination of December 2017 for 4 marks, right? December 2017 for 4 marks. Okay, so here we are having the 3 loops 1, 2 and 3, right? 1, 2 and 3. Okay, so out of that can we reduce the number of loops? Yes, here we are having the inner delta 2 ohm, 2 ohm, 4 ohm. Can we convert it into its star equivalent? Yes, so by using delta to star transformation we can get the circuit like this. Okay, so here it is a loop 1, here it is a loop 2. Consider loop 1 current is I1, loop 2 current is I2, right? Now when it becomes a 2 loop circuit, then we can simplify it with the same steps, right? Same as that of the previous example. Are you getting the point, right? So next what we are going to do, apply KVL to the loop 1, right? Apply KVL to the loop 1. So we can write plus V1 minus 1 into I1 minus 1 by 2 I1 minus 1 into I1 plus I2 is equal to 0, right? So from this V1 is equal to, we can write 5 by 5 upon 2 I1 minus I2, right? We require V1 and I2 in terms of I1 and V2, right? So we need to replace this I2, right? So let us keep it as equation 1. Similarly, can we apply KVL to loop 2? Yes, it is a plus V2 minus I2 minus 1 into I1 plus I2 is equal to 0, right? So rearranging the terms we can get the expression for I2 in terms of I1 and V2, right? I1 and V2. So it is minus 1 by 2 is like nothing but your H21 and 1 by 2 is the h22, right? Again we need to put this equation 2 in equation 1, right? Put this equation 2 in equation 1. So from this we can get v1, right? And ultimately final expression v1 is equal to 3i1 minus 1 by 2 v2, right? So by comparing it with the characteristic equations of the h parameters, so we can get h11 is 3 ohm, h12 is 1 by 2, sorry, minus 1 by 2 ohm, right? And similarly the remaining 2. Okay, so let us discuss one more example. Determine the h parameters of this given circuit. Okay, now in this circuit we are having 1, 2, 3 and 4 loops, right? So it is very difficult to simplify it, or it will be very lengthy if we simplify it by using the KVL, right? We can simplify it by using the KVL also, but it will take some more time, right? So instead of the KVL, it is better to go for the KCL, Kirchhoff's voltage law, right? So here we have considered the reference node voltage as 0 volt. Okay, next this node potential is V volt. Okay, next V1 here it is a V2 potential, right? So I have considered the loop currents as I1, I2, sorry, branch currents as I1, I2, they have already given. I have considered the remaining as I3, I4, I5 and I6, right? So can we apply KCL at V1? Yes, it is a incoming current is I1, which is equal to I3 plus I4. So I1 is equal to I3 plus I4, right? So after that we can write I1 is equal to, what is I3? V1 by 1 by using the Ohm's law, right? V1 is minus 0 is equal to 1 into I3. So what is I3? I3 is V1 by 1. What is I4? V1 minus V by 1, right? So similarly we can write I1 is equal to 2V1 minus V. Consider it as equation 1, right? Our expression for V1 I2 in terms of I1 V2. Okay, next can we apply KCL at the V2? Yes, KCL at V2. So from this we can write I2 plus I5 is equal to I6. So I2 plus I5 is equal to I6. So from this I2 is equal to I6 minus I5, right? Because we require the expression for V1 and I2, right? So I have taken at the left hand side I2, it is I6 minus I5. So can we replace I6 and I5 in terms of voltages? Yes, what is I6? I6 is V2 minus 0 by 1, so it is a V2 by 1, right? And I5 is V minus V2 by 1, right? So I have written here I2 is equal to V2 by 1 and I5 is V minus V2 by 1, right? So from this I2 is 2V2 minus V, right? 2V2 minus V, consider it as equation 2. Next, can we apply KCL at center node, that is a V? Yes, it is a I4 is equal to 2V1 plus I5, right? I4 is equal to 2V1 plus I5. So KCL at V. So from this replace I4 in terms of voltages, replace I5 in terms of voltage and the resistor with the help of Ohm's law. Okay, and further simplifying we can write V1 is equal to V2 minus 2V, right? So from equation 1 we can write V is equal to, from equation 1 we can write V is equal to, yes, V is equal to 2V1 minus I1, right? V is equal to 2V1 minus I1, 2V1 minus I1, and again we are going to put this V is equal to 2V1 minus I1 in equation 3, right? So if we replace this V with this V1 and I1, right, we will be getting the expression for V1 in terms of I1 and V2. Okay, so after that we can write V1 is equal to V2 minus 2 into 2V1 minus I1. Instead of this V, now we are going to put, instead of this V, now we are going to replace it with 2V1 minus I1. After rearranging the terms, we can get V1 is equal to 2 by 5 I1 plus 1 by 5 into V2, right? Next, we are going to put equation 4 in equation 2 and also equation 5 in equation 2. So let us check what is the equation 2. Yes, this is the equation 2, right? I2 is equal to 2V2 minus V, right? So first replace this V with the equation 4, right? So I2 is equal to 2V2 minus V. Instead of V, now we will be having, yes, we need to write 2V1 minus I1, right? So it is a 2V1 minus I1. So outside of the bracket there was a negative, so it will be minus 2v1 plus I1, right? So 2v2, and after that again we are going to put equation 5, that is v1, right? Whatever the v1 here, we are going to replace it with equation 5, right? So that's why I have written here. So from this, after that rearranging the terms, we can get I2 is equal to 1 by 5 I1 plus 8 by 5 v2, right? So what is the h11? It is a 2 by 5, h12 1 by 5, h21 1 by 5, h22 8 by 5, right? So here we are having the final solution. h11 2 by 5, h12 1 by 5, h21 1 by 5, and h22 8 by 5, right? So this is about the h parameters or the hybrid parameters, right? So so far for the two-port networks we have discussed about the all the 4 parameters, right? So in my next video we are going to discuss about interrelation between the parameters, right? Means how we can represent y parameters in terms of z parameters, abcd parameters in terms of z parameters, h parameters in terms of z parameters. Similarly, right, we are having total 12 conversions we are going to discuss in detail one by one, right? Thank you, thanks for watching.